So this one is classified paper 6, question from acid, base, and salts. In the question, a student is investigating the mass of a lead to iodide precipitate form when aqueous potassium iodide react with aqueous lead to nitrate. It's a precipitation reaction when we mix two salts or two solution and a solid is formed. So these type of reactions are known as precipitation reaction. And you should be able to write the ionic equation for the precipitation reactions. A student did 7 experiments. So 7 experiments student performed. He used 50 cm cube measuring cylinder and 25 cm cube of a potassium iodide was poured into a beaker by using 50 cm cube measuring cylinder means like the maximum capacity of this measuring cylinder is 50, but he only poured 25 cm cube using that. And then using a clean 50 cm cube measuring cylinder, 10 cm cube of lead to nitrate was added, and the solutions were mixed together, and a mass of a precipitate uh, which is formed was found, and the experiment was repeated using a larger volume of a lead to nitrate than in experiment 1, and so on. Till 7 times this experiment is done. So use a measuring cylinder diagram to complete the table. Just a minute, let me just rearrange. Yeah. Use a measuring cylinder diagram to complete this. Okay, so these are the results for the experiment, because we have to use this result and plot a graph. So it is 16, 23, 29, 39, 44, and 48. Okay. So we'll use this result to plot a graph. So plot the results for experiment 1 to 7 on the grid and draw two straight lines through the points and extend your straight line so they meet each other. So the first one, values I will write, the volume which we use, it was the volume which we used was 16, then 23 was there, then 29, then 39, 44, and then 48. And we have to plot a graph for mass of a precipitate. You can see here the mass of a precipitate and the volume of aqueous lead to nitrate, which was added. So first one, this is 16, the first one. Sorry, first one is 1.4 in 10. Volume of lead nitrate, so 1.4 in 10. So this was 10 and we have 1.4. So this will be 1. This will be 1, 2, 3, 4. So this is 1.4 and 10. The second value is 16 and the mass is 2.3. So 16 and 2.3. So each box is representing, because 10 boxes equals to 10, so each box is 1. So this 1, 2, 3, 4, 5, 6, so 16. And the second value was 2.3. So this is 2.1, 2, 3, and then 1, 2, 3, 4, 5, and 6. So this will be 16. The next one is 23 and 3.3. So 3.3, 3.1, 2, and 3. And till here is 16, 17, 18, 19, 20, 21, 2, and 3. So this will be 16 and, sorry, 23 and 3.3. Then we have 4.1, 39 and 4.1. So 39, this was 39. And this is representing 4, 4.1 is this. And then we have 44 and 5.1 and 48 and 5.1. So 40, this was already 39, this will be 40. So 41, 2, 3, 4, 44 and 5.1. This is 5, so this will be 5.1. And then 48 and 5.1, so same height. 39 and it was 4.1. So the values were 16, 23, 29, 39, 44, 48. And these values, and this was, there was a 10 as well in the beginning. There was a 10. This was 1.4. 1.4, 2.3, 3. I just want to cross check 3.3, 4.1. One of, okay, three of them are 5. This is 5.1, 5.1, and then 5.1. So this was 10 and 4, 1.4, then 16 and 2.3, then 23, 1, 2, 3, 23, and 3.3, then 29. Okay, yeah, there is one more, 29 and 4.1 was there. That's why this point appeared to be inaccurate. So this is 30 and 4. So this will be 29 and 4.1. And then we have 44 and 40, 5.1, and then 48, because 45, 6, 7, 8, and 5.1. And 39 and 5.1 is also there. So this will be, this was 44. So these are the points. We have to draw two lines. One is representing the increasing, and another one is a constant. That's how two intersecting straight line we will draw. So these are the two intersecting straight lines passing those points. And then from your graph, deduce the mass of a lead to nitrate precipitate that would form if experiment was repeated using 20 cm cube of a lead to nitrate. So if you use 20 cm cube of a lead to nitrate, how to work out that? You have to draw a line from your graph. When 20 cm cube of a lead to nitrate was used, how much mass is produced? So for us, like according to your graph, it's like example 2.9. So you will say that 2.9. But this is according to your graph, you will write the answer. Then explain why the same mass of a precipitate form in experiment 5, 6, and 7. Why the mass of a precipitate is not changing here in this part? What is the reason? What might be a reason why the mass of a
Limiting
precipitate?
reagent runs out.
Yeah, limiting reagent used up. So, or one of the reagent which is limiting used up. Or you can clearly identify because we are increasing amount of lead to nitrate, and the other reagent was what was the other reagent? Lead to nitrate was reacting with potassium iodide. So it means the potassium
So
iodide
it
is,
ran out.
yeah, potassium iodide used up because we are increasing amount of lead to nitrate, but we don't find any change. So what we can conclude from this, we can say that at this point, the potassium iodide is used up, as potassium iodide is a limiting reagent. The next is sketch on the grid the graph you would expect if the all experiments were repeated using aqueous potassium iodide with a half concentration. Look, if we use a half concentration, what will be the effect on the result for a
Less
half?
steep.
Yeah, it will be less steep. And like the total mass of a precipitate which will be formed will become half. Like what is the maximum mass of a precipitate formed here? It is 5.1. So it won't be 5.1, it will be half of it. So if this is like 5.1 is formed, we reduce the concentration. So if we reduce the concentration, the mass of a precipitate form will also be half. So half of 5.1, it will be 2.55. So 2.55 for the same volume of this one. Why is the product decreased? Because we reduce the concentration. Like if I say I was using 2 mole per dm cube
Volume
and
was same. So
yeah,
moles
volume is
were
same.
are decreased as we decrease concentration.
Yeah, 2 mole per dm cube, I use 10 cm cube. And then the same experiment, I use the same volume, but with a half concentration. I use 1 mole per dm cube. So 2 mole per dm cube of volume 10 cm cube and 1 mole per dm cube of volume 10 cm cube. This will have more moles and this will have few moles or less moles. As a result, the number of the moles decrease. So what will happen? The amount of the product, moles of Ki or even moles of the one which we are using, like example they mentioned in the question, we use a half concentration of potassium iodide. Even if you, so we reduce the concentration of potassium iodide. Yeah, if the moles were same, then the final product will be same. But because in the question the moles are half, so the final product should also be half. So what will be the graph? Your new graph, like here the maximum volume is 5.1, so it will be 2.55. 1, 2, 3, 4, 5. So this is 2.6. So it will be 2.55 somewhat here. So your graph, a similar graph will be there, but the shapes will be same, but the amount of the precipitate will be half. Is it clear, this one? And you should label, like example, for which part we plot this graph, you have to label on this. So that is part E, so label E there on your graph. Is this clear? Why the precipitate mass will be half?
Yes, sir, clear.
Yeah, there is a marking scheme for this exercise I will share with you. The next part, you state using a 25 cm cube pipette to state why using a 25 cm cube pipette to measure a volume of potassium iodide would be an
Because
improvement.
it's more accurate.
So because it's more accurate, so as it can accurately measure the volume 25, and why 25 cm cube pipette could not be used to measure the volume of lead to nitrate in each experiment. Like if you see, the amount of a lead to nitrate was not constant. Like we use different amount of a lead to nitrate, like different volume of lead to nitrate. Variable volume were used. Like here you can see we were using 16, then 23, then 20, 31, then 41. Sorry, 29, then 41 was there, and then so why different volumes are used? Because pipette can measure only fixed volume. You cannot measure a variable volume. So pipette cannot be used as it cannot measure a variable volume. And so answer for this one, the pipette can measure a fixed volume. It cannot measure like 16 cm cube, 39 cm cube. Why not we say only 25 cm? It's the same thing if you mention 25 cm cube or a fixed volume, but I just specify that it's a 25 cm cube pipette. Describe how the solid led to, even if you mention it's a fixed volume, it's correct. How a solid led to iodide can be separated from a reaction mixture and its mass was found.
We
So
will
what we should
filter
do?
the reaction mixture and
Yeah,
then
good.
wash it with the distilled water and then dry it in the folds of filter paper, and then we can measure mass by balance,
So
electronic balance.
electronic balance. So we simply like filter it off, rewash and rinse, and then dry and reveal. So we will use filtration because it's a precipitate, solid is formed. Then we will wash the residue. Then we will dry and measure the mass.